Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today I'm going to be giving more math tips for the non-calculated portion of the PSAT. Today's questions will be centered around word problems. If you're new to my channel, I'll be putting time codes in the description box below so you can skip ahead to any part of the video that suits you the most. If you have any questions about what you see here, or even your own homework, remember you can put them in the comment box below, or visit me on Facebook at Tutor Me Sempai and tell me all about it there. When you find this video helpful, remember to leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. But without further ado, let's jump right into these word problems. So our first question of the day is a doozy. Look how much text we have here. And I'm not going to read all this right now because our first tip is actually read less. That is the name of the game. For these word problems that you encounter on the PSAT, you want to read less whenever possible. That is going to save you tremendous amount of time, especially as you deal with more and more word problems. If you can read less and still get the answer, then you're saving time as you go. So the first tip is to read less when possible. Now I say when possible because there are some word problems where it's going to make you read more of it, if not all of it, but there are some that you can get a lot of information out of just by reading the last sentence. So the second tip I have for you is read the last sentence first. That last sentence will kind of set the tone for this type of question. You read the last sentence, and if you have enough information to answer it, then you can skip everything above it. A lot of time for word problems, we have a lot of fluff and flavor text just to kind of give a whole scenario, a whole picture of what's happening. But on a time test, we don't have time to read all of that. So we read less when possible by reading the last sentence and seeing if we can go from there. So we're going to do these first two for this question and see if we can get our answer. So the last sentence says, according to the model, what is the meaning of the 3 in the equation? Now we skip up to the 3 and we're going to try to really read less. So I'm not going to read the first 3 lines of this. I'm just going to go straight to that formula, that model up top. And it says this, n equals 456 minus 3t. So they're asking about this 3 and what does it mean? Well, even if you don't recognize this as slope-intercept form, you realize we have a number here and it's going to get lower as t increases. But it's not going to get lower by 1. It seems like that 3 is going to force it to drop by 3 every time t goes up by 1. Conversely, you can say as t decreases, we're going to subtract less from this number. So as t increases, we're going to subtract more by 3. And as t decreases, we're going to subtract less by 3. So let's look at our answers and see if we can find the right one just from what we know here. So answer A says, for every increase of 3 degrees, 1 more cup of hot chocolate is sold. Well, that says increase and 1 more. We said as t increases, something gets less, right? As t decreases, something gets more, but as t increases, something gets less. So A is not looking too favorable right now. All right, so let's go to B. For every decrease of 3, 1 more hot chocolate will be sold. So B is kind of still in the running here. We have a decrease and an increase, which is pretty much what you saw here, right? How about C? For every increase of 1, 3 more get sold. That's once again an increase, right? Increase, increase. So C looks like it's going to be out. How about D? For every decrease of 1, 3 more cups get sold. So we have decrease, increase again. So it looks like B and D are our potential answers, right? Once again, that's because as t increases, we're going to be subtracting more from this. So our overall number, if n is supposed to be our total number, our overall number is going to get smaller. However, as t decreases, as t gets smaller, we're going to subtract less by 3. So let's look back at B and D. It says for every decrease of 3, 1 more cup of hot chocolate gets sold. And for D, every decrease of 1, 3 more cups of hot chocolate get sold. So I would say, hey, in this case, it's fine to peek. Peek at your text up top and try to make sure you understand what the variables mean. And I see N is number of hot chocolates sold, and T is degrees Fahrenheit. So just wanted to make sure I really understand what that N is and that T is. However, you don't want to read everything else. Just hone in on what you need to know. So that N, number of hot chocolates, and that T, degrees Fahrenheit. So with all of that information, we can actually answer this question. For every decrease of 3 degrees, we're going to sell 1 more hot chocolate. Well, that doesn't seem to be the case here. If T is going to decrease by 3, yes, we're going to sell more, but it seems like we're going to sell way more than just 1 cup, right? If we go from 3 to 0, for instance, we're going to go from subtracting 9 to subtracting nothing. That's more than 1 cup. So it seems like B is out of here, which leaves D. And you can check your work if you want, but it seems like we've eliminated everything else. And in doing so, we revealed 2 more tips. So tip 3, peek if necessary. And tip 4, plug in numbers. You see we plugged in 3 and then we plugged in 0, right? Because it decreased by 3 for one of our options. We plug in a number and see what happens. So by using these 4 tips, we were able to skip a lot of the unnecessary wording in this word problem and still get our answer of D. So let's use these 4 tips for another question. So our second question also has quite a bit of text here. So let's see if we can read less with our first tip by reading the last sentence first. So the last sentence says, if Giovanni buys 2 shirts, which equation relates the number of sweaters purchased, P, and the total cost in dollars, Y? Well, I think that last sentence gives me a lot. It might not give me everything, but I think it can give me at least 80% of what I need to know. So this last sentence tells me that this question is going to have me try to set up an equation to find our total cost. And they tell us what total cost is as far as variable goes. It is a Y. And because Y is total cost, we know that Y is going to equal some expression. So Y equals is going to be kind of what my equation should look like. So we can go straight to our answers A, B, C, and D and see if we already have something looking like Y equals. So A, B, C, and D. So we have a Y equals for A, so we're going to keep A, but we don't have a Y equals for B. We have a 0.92Y. So that doesn't really scream out, hey, this is going to be my answer. We want to try to find Y equals because we want to try to build this equation to solve for Y. Likewise, for C, we don't have Y by itself. We want to have our Y, our total cost, by itself. D does have Y by itself. So you see, just by reading that last sentence, I've already eliminated 2 of my possible answers. Now we're just looking at A and D. And when we look further at A and D, you'll notice that it's almost identical. The only difference is we have a 1.08 and a 0.92 down here, but everything else is the same. So let's peek and see if we can figure out what these numbers are. But before we peek, realize that this is supposed to be finding a total price. So by multiplying 1.08 and multiplying 0.92, it's doing something to this price before we have it equal Y. 0.108 is going to be increasing the price, right? And 0.92 is going to be decreasing the price. So if we're buying shirts and sweaters, what would increase the price? Well, that's going to be some kind of sales tax, right? But what would decrease the price? A discount. So before we even peek, we can already know what we're looking for. Are we looking for a sales tax or are we looking for a discount? So let's look up. Do we have sales tax or discount? And that's going to pretty much tell us which answer is the correct one. And immediately my eyes go to 8% sales tax. I don't even read that first sentence. Sales tax jumps straight out at me, which makes me believe, hey, I'm going to have to add more money to this before I can pay. Sales tax always increases your value. And this is the only one that increases the value, right? We have a decrease here and an increase here. So D is not our answer. A is our answer. And we didn't have to look at that first sentence. Not all tips are necessary all the time, but it's good to have them, especially when you're dealing with these word problems. So before we move on, I just want to highlight this when possible in our tip 1. There will be times where we can't do what we just did. We solved most of this without even reading majority of this question here. However, there will be times where your problem will kind of need you to read more and not necessarily follow this first tip. So let's look at our next one and you'll see what I'm talking about. So our last question once again has a lot of text. So if you were trying to read less by skipping to our last sentence, you see we might come up a little short here. So our last sentence says, what is the elevation of the road in meters at the point where the truck passes t seconds after entering the road? Wow, let's read it one more time. What is the elevation of the road in meters at the point where the truck passes t seconds after entering the road? So unless you are some genius with a lot of foresight or some other special ability, I'm not that. I need a little bit more information. I can't even begin to solve this without understanding a little bit more about this question. And looking at our answers, they all seem relatively similar. They all have 1300. And they're all subtracting something. The only difference is what they're subtracting. So let's read a little bit more in this case because we really don't have much to go off of. Going back to the top, it says a truck enters a stretch of road that drops 4 meters in elevation for every 100 meters along the length of a road. The road is at 1300 meters elevation when the truck entered. The truck is traveling 16 meters per second along the road. So we have a little bit more information. We have the truck's speed. So I'm going to say TS. That's the truck's speed, which is 16 meters per second. And we know that the road drops 4 meters in elevation for every 100 meters along the length of the road. So we're going to see elevation drop 4 over 100. For every 100 is going to drop 4 meters. We don't have to necessarily pay attention to 13 because every answer has 1300. But we can start eliminating without having to do much else now. If we look at C and D, just off bat, we're subtracting a rather big number. If we're only dropping 4 meters for every 100 meters of road, C and D seem very far off. C is saying for every second you're traveling, you're dropping 4 meters. That's not true. We're only traveling 16 meters per second. For this to be true, we need to travel 100 meters per second. And that's not what's happening. So C is wrong. Similarly, D is also very off. This is saying we're traveling even faster. So this is automatically going to be gone. Since C was gone, D has to be gone. We're traveling way faster in D than we were in C, and C was even too fast. So let's look at A and B. Those seem relatively small numbers that we're dropping off, which is a good sign. However, A looks to be a little off because it says we're going to be dropping 0.04 for every second. However, what happens if we only travel 1 second? Let's plug in 1. Tip 4, plug in some numbers. 1 second. We technically would have traveled 16 meters. All right, cool. How about 100 seconds? That's 1600 meters, right? Which would cause our elevation to drop 16 separate times at 4 meters each time, which is way more than what we get when we plug in 100 seconds into A. So A is dropping off too slow. Too slow. Where C and D were too fast, A is too slow. So B is our correct answer for this. So we couldn't just read less by reading the last sentence. We had to read a little bit more. So we did a little bit more than just peek, but we did plug in some numbers. So I hope you have followed along to these examples, and I hope you found today's tips helpful. Remember, the name of the game is to read less whenever possible. With such large paragraphs littered throughout the PSAT, you can slowly eat up a lot of valuable time that you can otherwise save if you follow these tips. Now remember, you won't be able to use all the tips, and there will be times where you have to read the question in its entirety to get really what they're asking for. But be on the lookout for those special ones that you can just skip right to the last sentence and still find your answer. If anything that we covered today left you with questions, feel free to put them in the comment box below. And if you have questions about your own homework, feel free to tell me all about it on my Facebook page at Tutor Me Sempai. If you haven't done so already, remember to leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped in your PSAT prep, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.